Okay. Can you hear me loud and clear? Okay. I'll share my screen. Okay. Kita mo yung screen ko?
Ano po?
Kita na? Oops. Ayan. Oh, kita?
Kita na po.
Kita naman. All right. Okay. So, start na tayo, no? Early to bed, early to rise. Para matapos din tayo kagad. Hopefully, mabilis lang tayo tonight. Okay. Nung nakaraan, ang pinag-usapan natin is idealized auto cycle o yung standard 4-stroke auto cycle. Ngayon naman, ang pag-uusapan natin is idealized 4-stroke diesel cycle. So ano yung difference nung sa diesel cycle at saka doon sa auto cycle? Doon sa diesel cycle, ito ay tinatawag na constant pressure. Okay. So doon sa auto cycle, ang energy in natin or the source of our spark or heat to start the combustion process is a spark plug. Constant volume, meron tayong spark plug, nagkaroon tayo ng combustion process. Sa diesel cycle, ang premise naman natin ngayon is constant pressure. So, yung pressure doon sa air-fuel mixture is so high that it reaches yung, ang tawag dito, may tawag doon flash point. There you go. It reaches the flash point ng air and fuel mixture. Ang flash point is yung temperature of a substance to which it could combust by itself. So as you increase the pressure, you will also increase the temperature kasi PV is equal to MRT, di ba? Increase in pressure is equal to increase in temperature. So as you increase the temperature, it also increase the temperature. As temperature is high enough that it reaches the flash point, then you will have a spark, then you will have your combustion process. So yun ang premise ng diesel cycle. So dito ngayon, ang nakalagay ngayon sa screen natin is the PV diagram of the diesel cycle. So mapapansin mo, no? Draw. Okay, ayun. So mapapansin mo, merong konting difference doon sa auto cycle natin. Mainly itong part na to. Doon sa auto cycle natin, pag ganun yung, yung graph natin, pag ganyan. Pero dito ngayon, meron tayong pag ganito. Horizontal na siya. So that's the main difference nung diesel cycle at saka nung auto cycle. So let's analyze point by point. Take note, hindi ito 2-stroke cycle. Ito ay 4-stroke cycle diesel cycle. Okay, 4-stroke diesel cycle. Hindi tayo 2-stroke diesel cycle. We are analyzing the 4-stroke diesel cycle para apple to apple comparison doon sa auto cycle. So yung auto cycle natin 4-stroke, yung diesel cycle natin is 4-stroke din. So let's see. From process 1 to 2. Process 1 to 2, parang doon sa auto cycle natin, it's an isentropic compression stroke. All valves are closed. So yung formula natin at saka yung relationship natin between temperature and volume is still same. Parehas dun sa auto cycle natin. Where T1, the ratio of T1 and T2 is equal to the ratio of V1 and V2 raised to K minus 1. Yung RC is yung compression ratio mo. Since V1 over V2 is the ratio between the top dead center and the bottom dead center. So ito ay yung compression ratio. Okay? At this point, Q is equal to 0, pero dahil meron kang change in volume, meron kang work. So, work is equal to CV. Ano yung CV? CV is the specific heat at constant volume times the change in temperature. Next, process 2 to 3. Okay. Process 2 to 3, ito yung heat intake. Kaso, dito sa heat intake natin, meron din tayong change in volume. So, meron din tayong work. So, process 2 to 3 is heat intake. Heat is equal to MCV delta T or MCP delta T. Yung CP is since the constant yung pressure natin, this is the specific heat at constant pressure. Yung K is the ratio between the specific heats at volume and pressure. Tapos dito sa point 2 to 3, ang ginagamit lang natin yung specific heat at constant pressure. Since yung yung mass natin is yung mass ng air tsaka yung mass ng fuel, so pwede natin gamitin yung air-fuel ratio plus 1. So yun lang yung ibig sabihin nito. Oops, sorry. Ibig sabihin nito at saka ibig sabihin nito. Okay? Pero pwede mo rin sabihin na kapag wala kang M, pwede mo rin gamitin ito. Pero yung unit mo magiging kilojoule/per kilogram. Kasi walang M. Question so far? O apat na tayo ngayon. Tatlo na yung dalawa yung nabutan. Question so far? Walang question. Can you guys still hear me? Baka naman wala na nakakarinig sa akin.
None po, sir.
Okay, none. Okay. Okay, so tuloy natin ha. So, process 2 to 3, meron tayong change in volume. Since na meron tayong change in volume, there is work involved. And work is equal to P, yung pressure, times the displacement or yung volume. So, the pressure at P2 to P3, since this is constant pressure, so your pressure mo ng 2 to 3, equal lang siya, times the change in volume, V3 sa V2. So, meron ka ng Q in, meron ka ring work. This is where the Otto cycle and the diesel cycle first. Meron ka ring work at this point of this segment of the process. Meron tayong tinatawag na cut-off ratio. Cut-off ratio is the ratio between V3 and V2. Ano yung V2? V2 is the start of your combustion process. V3 is the end of your combustion process. So the change in that is your cut-off ratio. Okay? So dito meron ka ng compression ratio, V1 over V2, at meron ka rin cut-off ratio, V3 over V2. Next. Process 3 to 4. Process 3 to 4, kabaliktaran yung process 1 to 2. So, isentropic power or yung compression expansion stroke. All the valves are closed. So, kabaliktaran yung kanina nag-compress ka, ngayon naman dahil sa compression process mo, mag-expand ka naman ngayon. At manual is the mechanical harnessing of the combustion process. So, kabaliktaran lang din, P1 over P2 is equal to V1 over V2. Ginagamit natin yung relationship nila raised to the specific power, raised to the power of the specific ratio of the specific heat in constant volume and constant pressure. So, which is K. So, yung 3 to 4, meron ka ring work. Since there's a change in volume, meron ka ring work dito. So, mali ito. Type ito. Hindi ito work at 1 to 2. Version natin ito. This is work at work at 3 to 4. 3 to 4. Yun. So this is work at 3 to 4. So same lang din, no? Since na change in volume tayo, we can use specific heat in terms of volume times the temperature difference at 0.3. Next. Thermal efficiency. Thermal efficiency natin is the ratio between the heat in and heat out. Ang heat in natin is nasa process 2 to 3 and dito yung compression combustion process natin. At yung process 4 to 1 naman, ito yung heat out. Kasi ito yung exhaust point. Ito natin sila type ayan. Anyway, so yung Q in natin, MCV delta T, where M at Q in is equal to the M at Q out, so it will cancel out. So may kulang sa iyo ngayon is yung CP at saka yung CB at saka CP. So pansin niyo, doon sa Q in, ang ginamit natin specific heat ay specific heat at constant pressure. Doon sa process 1 to 4, ang ginamit natin CP is specific heat at constant volume. Okay? So, makikita nyo dito, process 1 to 2, P is constant. Dito, B is constant. So, ang ginamit dito, CB, dito ginamit natin CP. Ayun yun. CP, CP. Constant heat, specific heat at constant volume, specific heat at constant pressure. Since the ratio of CB and CP is equal to K, ayun yun. Kaya masisimplify mo yung formula. So yung CB at CP simplified naging K. So 1 minus temperatures divided by K times difference in temperature. Now, doon sa isentropic process natin, itong T1, saka T2, T3, saka T4, kung papansin nyo, ito, meron tayong relationship in terms of volume. Okay? If you substitute those relationship dito, makakakuha ka ngayon ng ito at saka ito. Since itong itong 2 to 3 is your ang tawag dito, 2 to 3 is your cut-off ratio. Ayun siya. Ay, tama. Ayun siya, cut-off ratio. Para makuha yung ano naman, yung since yung 4 is equal to 1, saka yung 2, meron kang compression ratio. Okay? Sample problem tayo. Sample problem. A small truck has a 4-cylinder, 4-liter compression ignition engine that operates on a standard diesel cycle. So idealized diesel cycle tayo. Compression ratio is 20:1 and the cutoff ratio is 2. The fluid is 100 kilopascal, 20 degrees Celsius, and the chamber is 500 cubic centimeter before the compression stroke. So before the compression stroke means dito sa part na to. So 0.1, ito yung 100 kilopascal at ito yung 20 degrees Celsius. So binigay din sa iyo yung Q in natin at 583. Binigay rin sa iyo yung R. So ito yung ano natin, yung specific to our air fuel mixture. So binigay rin sa iyo yung CP at saka yung CP. Specific heat at constant pressure and specific heat at constant volume. Question. Ang question ay pressure and temperature at each stage of the process. Saka yung thermal efficiency ng process na to. So let's start. First, meron tayong P1 at T1. Ito yung given kanina sa problem. to be able to makuha yung mass o yung amount of air-fuel mixture na meron tayo dito, ginamit natin yung PV is equal to MRT. Given yung R, given yung T, given din yung V. Yung V sinabi dito na 500, ayun. Ayun. Oops, sorry. Ayun. This is our V1. At the chamber volume is 500 cubic centimeter volume, which means maximum volume, which means bottom dead center. So ito yun, bottom dead center. 500 cm. So meron kang V1, meron kang P1, at meron kang T1. So gamitin natin yung formula, PV is equal to MRT. You'll be able to get M. Where M, it can be calculated as ito. So makapansin niyo, no? Yung R, yung unit ng R, ito. Ayan. So pag binalikan mo dito, R, ito, joule. Ito, cancel out na to. Ito, kilogram, ayun yung naiwan. Yung joule is yung pressure at saka volume. Joule. Question. Pa? Okay, tuloy natin. So meron ka ng PV, P1, T1, M1. M. P1, T1, V1. So ngayon, muna tayo sa process number 2 o sa point 2. So using yung ano natin, yung relationship natin, adiabatic relationship, isentropic process of the PVC, makukuha natin itong formula na ito. Ito yung formula natin nung unang-una pa. Ito, parehas din siya sa auto cycle. Itong formula na to. So pagka inikot-ikot natin siya, pabalik tayo sa formula na ito, makukuha natin ito. So simple lang, no? Ito compression ratio given sa atin kanina, 20:1. Ito, K natin is yung CV over CP natin. So we will get T2 is equal to, ayun, 970. Oh, go. Meron ka ng T2. Ano naman yung P2 mo? PV is equal to MRT ulit. Given na sa'yo yung M, na-calculate natin ng una. Given rin yung R. Meron ka ng T2. Yung V2 mo is equal to, ano? Compression ratio. So, given na sa'yo yung 500 divided by 20, meron ka ng P2. So, P2 is equal to, ayun. Ito naman tayo dun sa ano natin, point 3. Q is equal to MCP delta T. Ayan. Q is equal to MCP delta T. Ito given sa atin. Nakaka-calculate lang natin ang T2. Ito given, na-calculate natin nung una pa. Ito given. So meron kang may iwang T3. Where T3 is equal to, ayun. Using our adiabatic relationship again for the isentropic process, balik tayo dito. Compression ratio, ano ginawa ko dito? Oh, ginamit pala natin yung ano, yung volume, change in volume kasi kailangan natin yung V3. So, using yung V1 natin na 500 cubic centimeter, meron tayong compression ratio, we're able to calculate kung ano tong V3 na V2 na ito, which is ito. Using yung compression ratio. Ngayon, binigay sa atin yung cut-off ratio. Ang cut-off ratio is the ratio between V3 and V2. So meron na tayong cut-off ratio given sa atin at 2. So yung cut-off ratio can be calculated from V2. Ayan. So makukuha natin yung V3 natin. So V2, V3. So 2, ayan o, ito siya. 25 times 2, 12.5 times 2 is 25. 10 to the raise 6. Hindi siya cubic centimeter, meter cube siya, kaya siya naka-negative 6. Okay? Ganun din yung T2, T3 natin, no? Mapapansin nyo, yung T2, T3 natin, doble din siya. Parehas lang siya. Ginamit din natin yung cut-off ratio. Next. Using yung adiabatic process na tayo, similar to our process 1 to process 2, so process 3 to process 4, isentropic process using the adiabatic relationship. So, ginagamit na naman natin yung relationship ng specific heat at saka ng specific heat at constant volume at saka specific heat at constant pressure. You will be able to calculate yung V3 at saka T3. Using the relationship of V3, T3, you're able to calculate what is V4. Since yung V1 is equal to V4. Where T4 is equal to, ayun. So, meron na tayong temperature at each process. Isa na lang, pressure na lang. Pressure. So, same. PVT relationship, ayun. Yun din ang ginamit natin. Nakuha natin yung T4 at this month. Question. Question so far. Question?
None po, sir.
None. Okay, last na. Last is yung diesel cycle natin, yung kanyang energy efficiency or yung thermal efficiency niya. So, kapansin mo, dalawa yung ginamit natin. Una, ginamit natin yung relationship ng T1, T2, T3, T4 versus yung K. Ito ang nakuha natin. Saka yung pangalawang formula, ginamit naman natin yung compression ratio based on sa volume, yung compression ratio, at saka yung cut-off ratio. Since yun ay given, hindi natin pinalculate. Itong T1, T2, T3, T4, T2, T3, T4 is a calculated value. So based sa calculation natin, ito ang lumalabas na thermal efficiency. Kung mapansin niyo, based naman sa volume, which is given yung RT, yung compression ratio, at saka given din yung cut-off ratio, we are getting to the same number. So either or on formula na gamitin nyo, you will be able to get the same. Question? Wala. Walang question. So kung walang question, next week, guys, is our Module 2 exam. Final exam na. Wala tayong klase. Yung tulad ng nangyari nung sa Module 1, the Module 2 exam papers will be available pagpatak ng Thursday. And you have up until the end of Friday to submit your papers. All homework, kung meron man kayong na-miss out na homework para sa Module 2, you can submit it before Thursday. As long as hindi pa siya Thursday, pwede nyo pa siyang i-submit. Kapag ka Thursday na, hindi ko na siya pwedeng tanggapin. Alright. Your final grades will be the average of your Module 1 grade and your Module 2 grade. Kapag numeric ang grade ninyo, o numeric ang average ng dalawa ngayon, then congratulations, pwede na kayo magsalita. Question po. Wala. Let me stop my screen share. Stop screen share. All right. Any more question? Engineer Tenorio, Engineer Manalo?
Yes, sir.
None. If there's not, then thank you very much. I'll see you again next week. No, I won't see you next week. I will see you if needed sa week 11 in 2 weeks. Okay? Wala ng question, then thank you very much. I'll see you guys in 2 weeks. Okay. Paalam.